Hey there, students. I hope you are ready for some math. This is lesson 12.5. We're dealing with line plots. This is really kind of a one-off lesson. Most of the lessons we do kind of build on each other over several days. And this one's kind of just a lonesome wanderer because it's just, we have one lesson on line plots. They're pretty straightforward. What they require on the student end is what I like to call attention to detail, meaning that the students that um, can really sort of focus and go through these slow and smooth do really, really well with them. The problems are actually very easy. It just kind of takes a minute to kind of work through it to get to where you need to go. And so, yeah, so number one says some students compared the time they spend riding the school bus. Complete the tally table and line plot to show the data. So let's orient ourselves right here. Over here we actually have our data, and this is sometimes called the raw data, or I don't know. It's just the raw data. And so this one's not listed in order. It just has the numbers of, like, they asked one person, and one person said 1/6. One person said 3/6. One person said 4/6. And so it's not really in any order. It's just this is how the data came in. And so this is again time spent riding the school bus. And then over here, it's in a t-chart where we can have our fractions down the side, 1/6, 2/6, 3/6, 4/6. And then in here, we can provide tallies to help us track how many are on each one. And then finally, over here, we have our actual line plot, um, which is going to be our graph to show, to help us visually represent the data that we've collected. So really, by the time this is all done, we're going to have this exact same thing in three spots. We're going to have over here, which has it in no particular order. We're going to have that same data over here that puts it in a tally chart for us. And then we're just going to go one more step to make it look nice and pretty and put it into this final line plot. So let's get to it. So the first thing that I do is I always take the raw data over here and I put it into the chart. And it's pretty slick. It's actually really not too challenging to do. So I can say 1/6 is the first one. So I'm going to put an X under 1/6. And then the next one over is a 3/6. So I'll put an X in 3/6. The next one over is a 4/6. Yep, and there's a 4/6. After the 4/6 is a 2/6. So I'll put an X in the 2/6. And then another 3/6. So I will put another X in the 3/6. And then a 1/6. So I'll put an X in the 1/6. And then 3/6. And then 3/6. Don't worry about these big X's. That was just Google capitalizing it for me. So one quick way to check, and I always like to double check with data because you don't if you have kind of an error in your data, it can mess up everything. So I collected 1, 2, 3, 4, 5, 6, 7, 8 pieces of data got put into my tally box. I like to go back over and always count my raw data just to make sure those numbers line up. So 1, 2, 3, 4, 5, 6, 7, 8. That's great news. There's 8 numbers over here and 8 numbers over here. Now, if you really want to get technical, you can say, okay, I got 2 tallies in the 1/6 column, so that's 1/6 and 1/6, 1 in the 2/6, 4, 3, 6, 1, 2, 3, 4, and then 1 of the 4/6. So you can do that as well, but it's really important to make sure that this box here gets accurately into this tally chart over here. So then the next step we're going to do is we're going to take this data that's now in the tally chart, and then we're going to go in and put it over here on the line plot. So they've already done the 1/6 for us, that there were 2 people. Each X means a person. There are 2 people that said that they spent 1/6 of an hour on the bus. So then for the 2/6, let's see if I can actually do a chart like this. This will be interesting. 2/6, there was just one person. So let's try and get that X down lower. That might be too low. And then I'll just scooch it over just a little bit. I know it's not going to look like, say, yeah, that looks okay. All right, and then the next one, 3, 6, there was 1, 2, 3, 4 people. So I can do 1, 2, 3, 4. And then I'll just move that right up there. Try to have your, you want your X's to line up, like the bottom X to kind of be in the same spot. But, I'm doing this on a Google slide, so we kind of take what we can get. And then the last one is 4, 6, and there's only one person who said they went 4, 6. And so that would be just one X. And normally in the classroom we'd be doing all this on paper, of course, but we're digital right now. And so that's how you make a line plot. It's really not too bad. This middle step, once you get good at making sure you're accounting for all of the raw data, eventually this middle step can kind of be cut out because this is really showing the same thing as this. It's just the line plot is flipped over instead of up and down. But for now, it does really pay off to be careful and okay, let's get the raw data, put it in the tally chart, and then do the line plot last. So then now there's two questions that we can ask. How many students compared times? So all that's asking is how many people were there that responded to the survey? It's how many students were there? So to do that, I have to remember that each X represents one person. That represents one person saying that's how long they rode the bus for. So I can count and go 1, 2, 3, 4, 5, 6, 7, 8 X's. That's, oop, I don't want to do that. No, click over here. Oh, I never did a text box down there. Well, we can put in a text box. But there were 8 students. 8 students who said that, who responded to say that they rode the bus. Now, number 3, this is a trickier one, so I want you to listen very carefully. This one says, what is the difference between the longest time and the shortest time students spent riding the bus? Now, line plots are great because they give us lots of different kind of data. They tell us the different times that people spent riding the bus. They tell us the number of people that ride the bus. And it also tells us the distance that each one rode. So 2 people had 1/6, 1 had 2/6, 4 had 3/6, and 1 had 4/6. So with these questions, we just have to really figure out what the question is asking us. So what is the difference between the longest time and the shortest time students spent riding the bus? Well, let's look at our line plot and see what the data tells us. So the longest time. Well, what was the longest time students spent riding the bus? I notice the label here says time spent on the school bus. So my options are 1, 6, 2, 6, 3, 6, 4, 6. Out of those 4, I know 4, 6 is the longest. So 4, 6 was the longest amount of time spent riding the bus. And if I take a look at this, the difference between the longest and the shortest time, 1/6 was the shortest time. So if it's asking between the difference between the two, that means subtract. We know that difference means we're comparing two objects or two amounts, and we're trying to see how much greater one is than the other. And to do that, we have to subtract. So 4/6, which is the greatest amount, minus 1/6, which is the smallest amount or the least amount. Let's maybe space that out there. So 4/6 minus 1/6 is going to equal, well, 4/6 minus 1/6, we've done that before, equals 3/6. And that's how you solve both of those problems. So, the main thing with this one is that, we'll be thinking about how to make a line plot, but then also how can we answer the questions from the line plot. So, thank you so very much for watching this video and good luck on your math today.